Okay, everybody, here will be hopefully a quick video on integration by parts. And I got one problem that I think is fairly easy, and then I have another one that I think is much more complicated. Okay, but they're both integration by parts, and I want to put them in the video together. So here's kind of the shortcut or the trick to doing integration by parts. We look at our original integral and we see that one of those things is a function called f and the other is a function called g prime. G prime being the derivative of g, whatever that is. But you look at it initially like this. And you decide which is which by going through this acronym here. You read it from left to right. You identify what kind of functions you have, and you make your choice. Now, in my case right here, I've got an exponential function, and I have an algebraic. If I were to read it from left to right, I see a come before e, and so that means my choice is that I see what I have here, such that f is the algebraic function, which is 2x, and g prime is the exponential function, which is e to the 3x. Okay. And that's what we do to get started. Now, in this context, with this being something that I choose, the formula for integration by parts looks like this. Okay, we see our problem as, let's write it like this. We'll say we see our problem this way. The original integral is f times g prime. And once you make your decision about which of those is what, it's f times g minus the antiderivative of f prime times g. That's how you do it. You make your choice about what f and g prime are, and then this will become your answer if you work it out further. Okay, so let's see. Obviously, we got f and g prime. We need f prime and then also g. Okay, so here goes. F prime, what's the derivative of 2x? It's just going to be 2. G, well, g is whatever you take the derivative of to get e to the 3x. It's the antiderivative of e to the 3x. Now that will be e to the 3x over 3 if you use a little bit of u substitution. But that's what you'll get. And you can check it. You can take the derivative of this that I'm calling g and see that that really is g prime. Okay? But, nonetheless, this will always be the antiderivative of g prime. That's how you're going to find it. Whatever technique you want to use to do that. All right, now I have everything I need. Here's the generic formula. So it's going to be f times g. So we'll say, I guess you get 2/3 x e to the 3x. That's what you get if you do f times g. Okay? And I just put the constant 2 in over 3 together. Minus the antiderivative of f prime times g. Okay, so f prime times g, that's going to be 2/3 again, e to the 3x. Okay, so that's what you get. Now, we've always got to be able to work this out, to get a final answer. This may be what you do to get started, but you have to know how to do that one. All right, so like here, we have to know how to do this one. Maybe to help us out, I'll do this. I'll say 2/3 x e to the 3x minus, and we got the 2/3 right there. Let's just go ahead and see that as a constant and remove it, like so. Now, so you could finish this if you knew the antiderivative of e to the 3x. Okay? Do you? What's the antiderivative of e3x? E to the 3x over 3. By u substitution. Okay, so yeah, we know the antiderivative of e to the 3x is e to the 3x over 3. So it's going to be 2/3 times the answer to this. So we'll get a final answer at that point. 2/3 x e to the 3x minus 2/9 e to the 3x plus c. 2/3 times e to the 3x over 3. 2/9 e to the 3x over 3. Okay. And then we're done at that point. And that's a fairly basic integration by parts problem. But, just make the note to yourself that to address this part right here or that part right there, then we have to know how to do the u substitution to handle it. And it's just how it goes. All right? Okay. So that's what I would consider a fairly simple integration by parts formula. Now I'll take one that's more complicated. All right, this one right here. Okay, and to give a little background for this, it's an important kind of integral. It turns out that if you say take, like here's a problem from another course called Differential Equations. And it talks about how if you had like an insulated box, like a cooler or a building, and the temperature on the outside was fluctuating, could we predict how the temperature on the inside was fluctuating? If you try to solve that problem, you will run into that integral that you see right here. This or one that's like it. All right? Okay? So let's just get right down to it, and I'll show you how you work this one. It is integration by parts, so we can use whatever technique is appropriate for that. And so I would say that this is what I recommended on the other problem, so let's use it here. I have to choose among what I see there, f and then g prime, given that I have an exponential function and a trig function. Okay, so f comes first, right? You read it, you get the t first, the trig function, that's f. So f is going to be sine x. Okay? G prime, then, on the other hand, is going to be the exponential function, e to the 2x. All right? Now, at this point, I could say, well, like, there's your formula. You make the decision, and then you follow through with it, okay? So I had made this decision. I need f prime, okay, cosine, and I need g. I need the antiderivative of e to the 2x, okay, whatever that might be. It's going to be by u substitution e to the 2x over 2, okay? So there's u substitution again, right? I don't mind showing you the details on that, some other time, but for the sake of this video and this problem, that's what you're going to get by u substitution. Okay, so I have everything. Let's fill in the rest of it the way that the integration by parts formula tells us. It's f times g, so we'll say we get like 1/2 sine x times e to the 2x. Okay? 1/2 sine x e to the 2x, that's f times g, minus the antiderivative of f prime times g. Okay? Or that turns out to be, let's put a 1/2 out here. Okay, because if you multiply f prime times g, you're going to have a 1/2 e to the 2x cosine x. Okay. And we get that. Now, remember the catch with the integration by parts is, that's the formula that I get. That's all according to me doing this. But, the whole catch is you have to know this one. Right? Normally that's how it works. Like, so here it's like, do you know the answer to that? You use u substitution, you can get it, okay? But here's the problem with this one. That's what makes this problem different than all the others. That is essentially the same kind of problem this is. It's an exponential times a trig. If we didn't know how to do that one, we're not going to know how to do this one. Okay? All right, so here's what we have to do this time. Let's say I'm going to call this just my first step. And I'm going to repeat the process on that and see what I can get. All right, now you're going to have to trust me that it's going to work. Okay? That's just the way it is. So let's say, all right, second step. We're going to repeat what we had tried to do with this one. Now we're going to try to do with that one. We're going to repeat the integration by parts. So we're going to repeat, and we're going to try to work e to the 2x cosine x dx. Now, you would make your decision the same way. F would be the trig function, g prime would be the exponential. So we'll say, all right, f is cosine. G prime is e to the 2x. F prime is going to be negative sine. And G is going to be, well, whatever the antiderivative of e to the 2x is, which is e to the 2x over 2. Sure enough, if you take the derivative of e to the 2x over 2, you get e to the 2x. If you use substitution to integrate that, you will get e to the 2x over 2. Okay, so I'm repeating it on this and see where I get, because otherwise I'm just stuck with that. Basically, it's the same thing as this. Looks like I'm going in circles, but we're gonna try it again. We're gonna repeat on that. So here goes. What does integration by parts tell you get from that? F times g, so we'll get a half cosine x times e to the 2x. That's f times g minus the antiderivative of f prime times g. Now I notice one of those is negative, so it makes this minus, it'll make it become a positive when you remove the constant of negative 1. But f prime times g with, again, a half, all right. When you do f prime times g, you're going to get a factor of a half, e to the 2x sine x. Okay, I get that. Now, it really would seem that you're going in circles, like, because you take an exponential times a trig, you work it, you get there, it's still exponential times trig. And if you didn't know the answer here, you don't know it there either. So you repeated it, exponential times trig. You took this and you repeated it. Now another one, but here's what I noticed. Those are the same. And so here's what I think. If I take this and I were to substitute all that up there for it, that I could indirectly solve for this and tell you what it is. Okay? Now, so here's what I'm going to do. I mean, I can't have it all on the screen at one time, but I'm going to take our original statement. I'm going to take what I found this to be, and I'm going to substitute up there. I'm going to have to take a negative 1/2 times that whole thing. Okay? I'm going to write that as my third step, right? If I do that, it will say e to the 2x sine x equals 1/2 sine x e to the 2x, which I'm going to write 1/2 e to the 2x sine x, because I like that order better. Then negative 1/2 times whatever this became, and that's this. So I'll get negative 1/4 e to the 2x cosine x minus 1/4 times the antiderivative e to the 2x sine x dx. Okay. So like 3 is like taking 1 and 2 and putting them together. Now, that looks big and complicated, I'm sure, but I'll give you an analogy. here's an analogy to what you're seeing there. It's kind of like solving the equation a is 5 minus 1/4 a. See, the entire goal was that you tell me what e to the 2x sine x dx, what the antiderivative of that is. That was the goal. Now I just see it as an element in this equation. So it's like, here's an algebraic equation. A is the variable. Could you tell me what a is? You know, this is a lot like that. Well, sure, you add 1/4 a to both sides. It's like a plus 1/4 a. That. And what's this? So 5/4 a. Okay. And then if you divide both sides by 5/4, multiply by 4/5, then we get just 4, right? Okay. So sure, you can solve it like that if you want to. It's just like this. If your goal is to tell me what the antiderivative of e to the 2x sine x dx is, take this term as a like term, move it over there, and then it leaves all these other terms on the other side which become the answer. Okay, so it's just like this one. Okay? Just like it, same thing. So how about this? We will add that to the other side. See this term right here? Say you wanted to solve for it, say what it was. You would add it. It's negative 1/4 is the coefficient. Okay? So it's going to look like this. If I add this to both sides, you know, it's sort of like, what's 1 plus 1/4 of the same thing? 5/4, right? So if we take this, move it to the other side, we're going to get 5/4 times the antiderivative of e to the 2x sine x dx. What is that going to leave? It's going to leave all that other stuff over here. It's going to leave this. It's going to leave this. Okay? Now, for me to really tell you what the antiderivative of e to the 2x sine x dx is, I have to deal with this coefficient. So I'll multiply both sides by 4/5. Okay? So you might see that this, once the constants are worked out, becomes 4/5 times that whole answer that you see up there. Okay? What's that? All right, let's do the math, and then we'll be done. So, e to the 2x sine x dx, the antiderivative of that is 4/5 times this. Okay, so that's going to be 2/5 e to the 2x sine x, and then 4/5 times that's going to be 1/5, so minus 1/5 e to the 2x cosine x. Okay, and then we get an answer. We reduce it. Okay, now it might be, I don't have a problem with this answer, but if you look on our lesson and you look at the answer up there, there's this common factor of e to the 2x over 5, and so is no big deal, but just so that when you look the answer up on the lesson, that can be factored out, and it's going to leave you with 2 sine x in here once you take e to the 2x over 5 minus cosine x. Okay? And then always plus c. Like once we're done, plus c. Like always plus that constant integration. Once I'm done, then I tack on the plus c. Okay, so that one is different, right? We had to repeat the integration by parts, and we had to substitute that repeated answer back up here, and then indirectly solve for what we were trying to solve for. The original question, before I even wrote anything, was, what's the antiderivative of e to the 2x sine x dx? Well, you can solve for it indirectly out of this equation. And I hope you see my analogy holds true, that it's really no different than you telling me what's the variable a out of that equation. It's like the same thought process, same manipulation of the variables. Okay? All right, so that's how you do what's, I believe, is question 11 in the integration by parts problem. Any questions from here, let me know. We can work more in class. But do 10 also. This is question 11. Question 10 is similar. It's actually a little bit easier than this, so try to do 10 as a follow-up to what you see here.